In 8.5, we're going to talk mostly about division involving radicals. So first we have the quotient property of radicals, and it says this. If you have the nth root of A over the nth root of B, that you can write that as the nth root of A over B. So if you have two separate radicals and they have the same index, and they're being divided, you can write that as one rational expression under the radical, okay? The indices have to be the same, though. N has to be the same. Sometimes we go that way. They give them to us separate, and we put them as one rational expression under one radical. And you'll see why we do that in a minute. Sometimes we go the other way, where it's one rational expression under the radical, and we split it up into two separate ones. Okay, so it works both ways. All right, so here comes an example. We have these two square roots, so the index is the same, and they're separated. So we're going to rewrite that as 1 square root of 50s cubed over 128s. Now the reason for doing this is we're going to hope that we can simplify that rational expression. So 2 goes into 50 and 25 times, and 2 goes into 128 64 times. So we're reducing it like we do a fraction, and then s can cancel with one of those s's, and we get s squared. So I have a big mess there, but it can be written as the square root of 25s squared over 64. Now what I'm going to do is I'm going to think about, and I don't have to necessarily write this, but I'm going to think about those separately. What's the square root of 25s squared, and what's the square root of 64? So now I'm going back the other way where I split them up. Like I said, you don't have to write that, but it might help you see what's going on at the beginning. So I get 5s in the numerator, and I get 8 in the denominator. And then there's no more square root on this one because we could take the square root of both 25s squared, and we could take the square root of 64. But see, at the beginning, 50 over 128, what were we going to do with that? So, okay. So here's another one. This time it's a cubed root. And I'm going to do the same thing. They're both cubed roots, so I'm going to make it the cubed root of 56a over 7a to the 4th. And again, I'm going to try to simplify that. So 7 goes into 56. I can think about canceling a 7 with a 56 and getting an 8. And then I'm going to think about canceling an a with one of those a's and having an a cubed. So now I have 8 over a cubed, or rather the cubed root of 8 over 8. 8 over a cubed. Okay. So I can take the cubed root of 8, that's 2. And I can take the cubed root of a cubed, and that's a. And so we're done. Now again, you could write those up separately if you wanted to, if it's easier for you to see that way. But you're taking the cubed root of both the numerator and the denominator. Okay. I think that's it for this video.